Hello guys, welcome to my channel. Today's our topic is soil stabilization techniques. In this video, we are going to discuss few of the main soil stabilization techniques which include mechanical, second one is compaction, and third one is chemical stabilization technique of soil. So in this video we will discuss the techniques, advantages and the purpose of soil stabilization. So let's get started. First of all, what is meant by soil stabilization? Soil stabilization is a process by which the physical properties of soil are transformed to provide permanent strength gains before construction. So, soil stabilization is to change the physical properties of soil to gain the strength or to enhance the strength of the soil before construction. You can say soil stabilization is the method of changing a natural soil to meet engineering purposes. To enhance the strength, why you are increasing the strength? To meet the engineering requirements or to enhance the bearing capacity of the soil so that the structure you are going to build should last for longer time, and it also saves your. We will discuss the advantages, purposes on upcoming slides. So here are few techniques discussed in this picture. As you can see over here, the soil chemical is being added in the soil to enhance its properties, and the old soil is being replaced by a new soil, or you can say by a some sort of stable and good quality of soil. So this is the definition of soil stabilization, and it is very important in soil mechanics. Now coming towards the purpose and advantages of stabilization. When the stabilized soil layer is incorporated into the structural design of the pavement, the subsequent layers can be thinner, resulting in a sizable cost saving and minimizing the need for virgin materials. If we talk about the pavements like roads, if the soil is mechanically you can say stable and strong, then the thinner layer will be required, or you can say lesser material will be required to bear the same quality of load. So it saves your cost, it saves the need for material. The second point is stabilized soil forms a solid monolith that decreases permeability, which in turn reduces the shrink swell potential and the harmful effects of freeze-thaw cycles. When the soil is stabilized, it is well compacted, it reduces the chances that the water will penetrate into the lower layers. So which result in the you can say less penetration of water and less chances of freeze and thaw cycles, which result in the stabilized soil and have greater strength as compared to a normal soil. What differences or what changes soil stabilization made? It include increasing the weight bearing capabilities, tensile strength and overall performance of in situ subsoil, sands and waste materials in order to strengthen the road pavements. So this is not only the case if we talk about the roads and only roads. It is also important in buildings. When you are building multi-story buildings, so the basement should have to be very strong. So different methods are applied to stabilize the soil. We will discuss these methods. First one is mechanical soil stabilization technique. This is the oldest type of soil stabilization and it is called as mechanical in nature. Mechanical solution involves physically changing the property of the soil somehow in order to affect its gradation. So we will have to change its gradation and solidity and other characteristics. Ultimately, dense and well graded material can be achieved by mixing and compacting. So mechanical stabilization involves mixing and compacting two or more soils of different grades. Addition of small amount of fine material. So what will you do is mixing what? First one is fine material. Fine material such as silts or clays enables binding of the non-cohesive soils, which increases strength of the material, and other mixing material is strong and angular particles of sand and gravels impart internal friction and incompressibility to the mix and can be well stabilized with addition of clay owing to its binding properties. So these are the two materials which we can mix in mechanical stabilization, and then compaction involves. Okay, so factors affecting the mechanical stability of mixed soil may include the mechanical strength and purity of the constituent materials, the percentage of the material and its gradation in the mix. So these are the few factors which plays very important role if you are adopting this method or this technique of stabilization. And the degree of soil binding takes place, and the mixing, rolling and compaction procedures adapted in this field, and the environmental and climatic conditions also affect the mechanical soil stabilization techniques. Here comes the second method of soil stabilization is compaction. Okay, uses mechanical means for expulsion of air voids within the soil mass, resulting in the soil that can bear loads subsequently without further immediate compression. And it involves two types of compactions. First one is dynamic compaction. Dynamic compaction is one of the major types of soil stabilization. In this procedure, a heavy weight is dropped repeatedly onto the ground at regular intervals to quite literally pound out deformities and ensure a uniformly packed surface. The second type of compaction is vibratory vibrocompaction is another technique that works on the similar principle, though it relies on vibration rather than the deformation through kinetic force to achieve its goals. In this picture, as you can see over here, this is conventional rolling with the help of a roller. Then there comes impact rolling, which have little impact up to the certain depth of the ground. Then rapid dynamic compaction. Then there comes dynamic compaction. In compaction stabilization technique, dynamic compaction, as we discussed over here, that a heavy weight is dropped freely onto the surface of the ground, which compact the earth surface. As you can see over here, as we go down, this is the possible range of this load. Okay, if we increase the load, the range will also increase. So it compact and consolidate the soil up to a certain depth, and the weight is dropped from a certain height to achieve the certain compaction of the up to certain depth. Okay, if we talk about vibro compaction, it is also the same technique, but it involves vibration, as there is a vibrator that we use in concrete. Similar vibrator or which have a more strength as compared to a concrete vibrator is used to compact, or you can say to remove, you can remove the air voids to compact the soil and consolidate it. Okay, then there comes chemical soil stabilization technique. This is the third type of technique. Chemical solutions are another of the major types of soil stabilization. All these techniques rely on adding additional materials. Chemical stabilization involves addition of another materials to the soil that will chemically and physically interact with it and change its properties. For example, cement stabilization is the most effective on low cohesive soils owing to difficulty in good distribution of the anhydrous stabilizer amongst cohesive clays, and becomes larger granular particles can be surrounded and coated by the cement paste. As you can see over here in this picture, cement is being sprinkled, or you can say spread on the soil, and then a little water is added, and then it is compacted. As a result, a solid, as you can say, this method is suitable for cohesive soils. Okay, so when water and clay reacts, it forms a solid mass. So these are the few techniques which we adopt for the stabilization of soils in soil mechanics or geotechnical engineering. So that's all for today.